Hello everyone, for this video I'm going to be looking at the characteristics of homologous series, and towards the end of this video I'm going to be doing some activities that relate to how to identify your homologous series a little bit. Alright, just a small information again, please subscribe to the YouTube channel. It helps me to make more videos for you to learn. Right, so characteristics of homologous series, you need to know these characteristics. I have seen short answer exam style questions that ask you about the characteristics of homologous series, so you need to know these. Right, so it says the members of the same homologous series can be represented by the same general formula. That is of course true. Not true, because the homologous series, if we recall, they contain the same functional group. It's a group of atoms, right? So they contain the same functional group and therefore the same general formula. So that's one thing, right? And it says, for example, each member of the alkane homologous series has the same general formula, CnH2n plus 2. And do you recall the one for alkene? Well, if you said CnH2n, you would be correct. Now, the other characteristic is that all the members of the same homologous series has the same functional group, referring to the group of atoms that give them the same or similar chemical properties. They react similarly, right? Another thing is that they differ from the members immediately before or after by a CH2 group, therefore differing in relative molecular mass of 14 g-mole. Right, so each member differ by 14 g-mole. Remember, member means number of carbon atoms. Right, it says all members are typically prepared using the same general procedures. Look at that. And that's for the same functional group, of course, such as the action of hot soda lime on the suitable sodium salt of an acid. Oops. Right, it's just talking about the preparation of the different compounds with the same functional group. So a compound might have 1 carbon, 2 carbon, 3 carbon. However, the similarities between these 3 compounds is that they have the same functional group, right? And so they would be prepared the same because of this functional group. Now, another characteristic is that they have similar chemical properties. I love this one. Right, that's a given because they have similar functional group. An increase in molar mass causes a decrease in reactivity. Look at that. So the higher the molar mass, the lower the reactivity, or the less the reactivity. They show a gradual change in physical properties as the number of carbon atoms in the compounds increase. Right, and note that they become more solid as the number of carbons increase. So it says generally as the molar mass increases, the density and the melting point and boiling point also increases. So it says as the molar mass increases, the density, melting point and boiling point increases. So that's a lot of characteristics right there. You got about, I'm gonna say 5 or 6 or 7, one of those. So let us recap about the characteristics of homologous series. They have the same general formula. They have the same functional group. Members in the same homologous series differ by 14 g-mole. Right? They have similar chemical properties. Reactivity decreases as the number of carbon atoms increase, as the molar mass increase. There's a gradual change in physical property as the number of carbon atoms increase. So change in molar, change in melting point, change in boiling point, and the density. Right, those increase. Right, and this also leads back to fractional distillation. Just recall that the higher or the more atoms that we have, the higher the boiling point will be. Right? Now it says importance. The homologous series aids in the identification of the structure of each consecutive member of the series, and the properties of those members can also be anticipated by their series. So what this is saying is that we can, if we know the homologous series, we can predict how to prepare this compound. We can predict the properties of this compound. So how will it bond with something else? How do we know that this is going to produce this gas? Right, so if we know the homologous series, we can tell distinctive chemical properties. Right, Now, down here it says select the options with the same functional group. Once again, recall that the functional group is a group of atoms that have similar chemical properties, right? And we have down here, I'm trying not to talk for too long, right? So I'm trying to go to 20 minutes or less. Okay, so ethanoic acid, as you can see, this is ethanoic acid here. It's COOH. Same down here, propanoic acid, pentanoic acid, the COOH. That's a functional group there. Propene, we have our C double bond C right there and C double bond C right there. And let me actually use down here. That's our alkene, and then we have the alcohol right there. All right, so we can see our functional group. Okay, nice, amazing. Let us scroll a little bit and we're gonna do this activity. I recommend after I do the first two, I want you to try the others on your own and see how much you know and is able to apply. So it says deduce the homologous series given the condensed formula. Now sometimes it's hard to tell the homologous series based on just simply the condensed formula. So if you are ever confused, draw it out. Draw it out, it helps. Right, so the first one is CH4. CH4. And we need to draw the structural formula. That's what we're going to do before we do our homologous series. Right, so it's 1, 2, 3, 4 hydrogens, and the carbon only has single bonds around it. So therefore, this is an alkane. Nice. Let us look at number 2. Number 2, let us draw it out. It has, so it's CH2 carbon. First carbon has 2 hydrogens. Second carbon has 2 hydrogens. Right? We cannot add any more atoms around the carbons, but we do need to check to see if we have the correct amount of bonds around each carbon. Right? So the first carbon has 1, 2, 3. That doesn't seem right because we know it needs to have 4, right? So I'm going to put another bond between our carbons right there, and let's just double check again. So it is 1, 2, 3, 4, and the second one has 1, 2, 3, 4. Right, so this is correctly drawn, and as we can see, it is an alkene. Let me use my pen. This is an alkene. Amazing. Now let us do the next one. We're at number 3. For number 3, it says CH3. So the first carbon has 3 hydrogens around it. 1, 2, 3. And there's no other carbons. However, there's an OH. So I'm simply just going to attach it to this one here. And we can remember that this OH right here tells us that, hey, that's our functional group, but our homologous series, of course, is alcohol. Right? Once you see the OH, that is alcohol. So pause the video and do the rest on your own. I'm going to just do the little explanation as we go. So number 4, it is CH3. The first carbon has 3 hydrogens. Second carbon has 2 hydrogens. That's where I'm at. Third carbon has 2 hydrogens. And then there are no more carbons, but there's an OH. Right? And because of this OH, this number 5 is, of course, an alcohol. Right. I hope we're understanding so far. Alcohol. Alright, now we're at number 5. Okay, number 5 has, the first one is 3 hydrogens. First carbon is 3 hydrogens. Second carbon is 2 hydrogens. But we can see the COOH. Right, so it's going to be C, double bond O, and OH. Nice. I'm trying to draw it so that the hydrogen, nice, that's amazing. But that's COOH. Once you see this right here, that's our carboxylic acid. Alright, so let me just erase this. Number 5 is carboxylic acid. Alright, number 6. Let's draw this one. Say it's carbon. The first carbon is bonded to 3 hydrogens. 1, 2, 3. The second carbon is bonded to 2 hydrogens. 1, 2. The third carbon is bonded to 1 hydrogen. And the fourth carbon only has 2 hydrogens. Whew. Something looks like it's missing, but it's not. And what we're going to do is that we're going to actually check to see if all the carbons have sufficient number of bonds. So the first carbon has 1, 2, 3, 4, so that would be correct. Second carbon 1, 2, 3, 4, that would be correct right there. Third carbon 1, 2, 3. So what we're going to do, since over on this side has full, it cannot hold anymore, we're going to do another dash right here. So it now becomes 1, 2, 3, 4, and now the fourth carbon has 1, 2, 3, 4. And because of this double bond, our compound is an alkene. And let us see if we can identify number 7. What do you think number 7 is? So we see the COOH, so number 7 is carboxylic acid. Right, let us do number 8. We cannot exactly tell what's going on there, but I'm going to bet it's an alkene. So let's see if it is. And the more you do this is the more you understand and you can pick up on patterns. So the first carbon for number 8, that's where we're at, it's 2 hydrogens, 1, 2. The second carbon is 1 hydrogen. The third carbon is 1 hydrogen. I don't know how that hydrogen got up there. Yeah, there we go. Third carbon is, this is where I'm at, 1 hydrogen. The fourth carbon is 1 hydrogen, and the last is 3. Oh, this one looks fun. So let us double check, because there seems to be a lot of things missing. So let us see which carbons would get double bonds. So the first carbon has 3, 1, 2. It has 1, 2, 3 bonds. We cannot put anything on the left because there are no other atoms on the left. So I'm going to put a double bond right here. Now that makes that we have the second carbon having 1, 2, 3, 4. So that is complete right there. The third carbon has 1, 2, 3. Right? And we can't put any on the left because the left carbon is complete. So we're going to put it on the right. Put it right here. Let us double check. So it's 1, 2, 3, 4. And the one on the right is 1, 2, 3, 4. Right? And the fifth carbon is 1, 2, 3, 4. So that would be correct right there. And as we can see, because of those double bonds, the functional group, the homologous series is going to be alkene. Now the ninth one is a little bit tricky because I know we see brackets and we're like, what does this bracket mean? Well, the bracket actually means branch. The bracket means branch. Let me just, and just in case you see it, at least you know what it means. So I'm going to draw right here. I'm at number 9. So it's the first carbon, CH3. It has 3 hydrogens. The second carbon has 1 hydrogen there. Remember that I said the bracket means branch, right? And for branch, we're coming off the straight chain and we're going to draw it down here, right? So the carbon that is branch, it has 3 hydrogens. So 1, 2, 3 right there. Now we're going to continue the straight chain and we're going to put our CH3 right here. Yes? Nice. Now, even though it's branch, all the carbons have single bonds between them. And so we say that this is an alkane. And of course, for the last one, because of the COOH, that is a carboxylic acid. Right? Nice. Awesome. We're almost finished with this part of the lesson. See, we're even at summary. So it says deduce a homologous series given the displayed formula. So looking at A is right here. What homologous series do you think this is? If you say carboxylic acid, then you are correct. B is alkane because of the C single bond C. C, this is C. C is alkene because of the C double bond C. D is alcohol because of the OH. E, alkane because of the C single bond C. This one here, we call this methanoic acid, very pretty. F is carboxylic acid, and G is carboxylic acid because of the COOH as well. So as you can see, a good way for you to identify the carboxylic acid is because of the C double bond O and the OH. Right, now that ends this topic right here. I hope you understand the difference between carboxylic acid, homologous series, I believe there's one I'm forgetting, and functional group. My advice, write your own definition for these three words and put an example for each. It really helps. And just remember, the homologous series, right, it's a group of compounds with the same functional group, right? And that's the name that we give these group of compounds. The functional group is a group of atoms, right, that have similar chemical properties. As you need to know the difference between the two. And as always, thanks for watching. I will see you in the next video. And note that we're going to be looking at naming next. So this part is quite exciting. You can start to read ahead. I'll see you then.